The solution is to become a scientist, because then you can be responsible for your own answers based on evidence. It's really letting nature guide you rather than pretending you know the answer in advance. And I'm saying, most stars formed billions of years before the sun. And so if there was a similar technological civilizations on planets like Earth, there could have been someone smarter than Albert Einstein on an exoplanet, another planet, billions of years ago. And there was enough time for that civilization, first of all, to develop much more advanced science and technology than we have, because we had it only for 1 century. And just think what will happen if we had it for 1 million years, for 1 billion years. But moreover, they had enough time to send these probes that would have arrived to us by over less than 1 billion years. So they could already be here, these probes. And that's not a philosophical question, whether they're here or not. It's just a question of looking up through our telescopes. This is another component of the Galileo Project, but the third one, which we already have a new observatory following, was inspired by the report of the Director of National Intelligence in the US in June 2021, around a month before we announced the Galileo Project, that there are unidentified aerial phenomena, UAP, objects in the sky that the US government is unclear about. There are some of these objects that were not identified, and the government publicly announced that it's a population of objects. And so the question is, what are they? They may be human-made, but even if one is of extraterrestrial origin and it's functional, it would have a huge impact on the future of humanity for us to realize that. I've been working in astronomy for several decades. I was the longest-serving chair of the astronomy department at Harvard University, 9 years. I was chair of the board on physics and astronomy of the National Academy. So I was part of the establishment for decades. And I know it very well, but I do think that, our knowledge is just an island in an ocean of ignorance. So we should be open-minded. Exploring the frontiers of science, in my mind, is similar to spirituality. You are exploring the unknown, and you have to be modest about it, because it can be bigger than you.
Hello, everybody, and welcome back to Chasing Consciousness. So today, we're going to be finding out about new developments in the SETI discussion. That is the search for extraterrestrial intelligence that's been prompted by the anomalous interstellar object Oumuamua that passed through the solar system in 2017. Since the cosmologist, skeptic, and TV presenter Carl Sagan helped to normalize the topic for serious scientific consideration, SETI's been a thriving, if underfunded, scientific endeavour, with multiple techniques being applied, not just listening for radio signals like Sagan's famous film Contact, but which until recently hasn't found anything to write home about, despite a few false alarms. Now, until the arrival of Oumuamua, our guest today wasn't really involved in the SETI debate, but his SETI interpretation of the data on this object and his impeccable reputation as former chair of the astronomy department at Harvard University has brought him into this debate with a bang. He's none other than the Israeli-American theoretical physicist Avi Loeb, Frank B. Baird Jr. Professor of Science at Harvard, author of over 700 scientific papers, and receiver of so many awards and accolades, I'm not going to try and list them here. He's also the author of 4 books, of which we're going to be discussing 2 today. First, his New York Times bestseller, Extra Terrestrial, about Oumuamua, and second, his new book that's just out, Interstellar, The Search for Extraterrestrial Life and Our Future in the Stars. Now, to add further taboo to this newly invigorated debate, we're also going to be talking about the 2017 New York Times story on military UFO encounters, which revealed that the US government had not only been secretly studying the UFO phenomena, but also covered the extraordinary tic-tac case around the USS Nimitz aircraft carrier in the early 2000s that was witnessed by multiple fighter jet pilots and included radar blip confirmation. And all of this has led to Congress passing a new law obliging military witnesses to testify about these incidents and also to testify about alleged black projects trying to develop this kind of technology. Well, having never known that this was even a really confirmed phenomena, and knowing that Avi has since been brought into the scientific debate on this, I really can't wait to get into this. So without further ado, let's go. So, Professor Avi Loeb, thank you so much for joining us on Chasing Consciousness. Welcome. How are you?
Thanks for having me. I'm doing great. Never been as good before. I jog every morning at sunrise, and I eat about half of my calories from dark chocolate. So I really have, I'm having a great time.
I have to say, listeners, I have never come across a guest who answers emails, first of all, so fast, but also at any time of the night, wherever he is. So I'm slightly worried by how much you sleep, Avi.
No, I actually sleep quite well. That's part of my healthy lifestyle. It's just that I wake up very early, and that's so that I can see the sunrise, which is different every day. The colors are different. And even if it snows or rains, it's just water. And I really enjoy nature in any form it comes along. That's all from my upbringing on a farm. You know, I grew up as a farm boy, and I used to collect eggs every afternoon and drive a tractor to the hills and read philosophy books there. I was really interested in the big questions, and I'm very attuned to nature. I see it as a learning experience for us to listen to nature rather than to each other.
Well, that's exactly my first question, actually. I love to ask my guests about the first time they sort of came into consciousness, usually in adolescence, and they started to ask deep questions about life itself and about the world around them. I mean, what can you remember, any pressing questions from that time that may have influenced your adult thinking?
Right. So the most striking thing I noticed as a kid was that the adults often pretend. So I would ask a difficult question at dinner, and the adults in the room, irrespective of who they were, if they didn't know the answer, they would dismiss the question or say it's not important, or just invent a story and move on, just so that they can maintain their image of knowing what they're talking about, or at least, you know, not admitting that they're ignorant about the answer to the question. And that was very frustrating to me. And the solution to this frustration is to become a scientist, because then you can be responsible for your own answers based on evidence. It's really letting nature guide you rather than pretending you know the answer in advance. Okay. And by the way, nature is not necessarily the most beautiful you can imagine. Obviously, if you put goggles of the metaverse, you might envision a reality that is far better than the one we live in. You might look like Brad Pitt, surrounded by celebrities, living in a very wealthy environment and so forth, and everything is to your liking. You look great, the environment looks, but that's not the reality that we all share. And what I really want is to see the pimples on the face of reality. And the best way to do that is to collect data and pay attention to evidence. On the first date with my wife, I asked her not to put any makeup. I want to see her the way she is. And so to me, if you are in love with nature, you want to see it with all its faults. You don't want to live in the metaverse where everything is to your liking. Mm-hmm. You don't want to have a theory of everything that is extra dimensions, the multiverse, where, you know, we have no way of testing the ideas by experiments. That is, in a way, that's heaven for theoretical physicists, to be working on a hypothesis that cannot be falsified. in principle, because then they maintain their stature. They can give each other awards and they can be very proud of themselves because it will never be proven wrong. But to me, that's not a satisfying lifestyle. To me, a satisfying lifestyle is one in which you grow, you learn something new that you didn't expect. And the only way to do that is by making mistakes, just like kids, like in Hans Christian Andersen's story, a kid would say the emperor has no clothes, even though all the adults would never say that. And that's because the kid is much more mature than the adults. The adults are childish in a way by trying to pretend all the time, pretending you know something that you don't really know. And science is supposed to be an activity by which you don't pretend. You don't have prejudice, you are agnostic as to what reality is, and you are learning about it from experiments.
Well, Avi, what a profound insight for a young boy, and so close to what we're trying to do here on Chasing Consciousness. We're really trying to just let the data speak for itself. We're listening to specialists on all sides of the debate because we want to hear how they interpret that data. And if there's any sign of them pretending, I think the public will probably smell it out pretty quickly.
One thing I wanted to comment on that is, as a kid, I really enjoyed reading existentialism as a philosophy, because in existentialism you basically admit the circumstances that you are born into, and you're not pretending that you are well above that. For example, I was born with some abilities that include my body in terms of my athletic abilities, also my brain in terms of my intellectual abilities and so forth. I can never brag about that because it's just like buying a car from a dealership. I know that many alpha males are very proud of their car, and especially if they're 40 or 50, they get a kick out of driving really fast and impressing other people. But it's not really up to them to be proud of it. It's whoever designed the car that should be proud of the performance of the car. And I didn't design myself, like my physical abilities, my thinking abilities. It was just given to me by my parents. So I can never brag about that. I can never take credit for that. I just live with that and try to understand it. It's as foreign to me as it is to you. I mean, my body is not I've never seen my heart. I've never seen my liver. I don't know how I look like from the inside. It was just given to me, and it's as foreign as anything else. And so it's really about being conscious and curious about everything we encounter, including ourselves.
Well, it's a wonderful point on humility in the face of the unknown. That is exactly the kind of attitude we need from our top scientists. So it's very reassuring. So, Avi, the main point for today, before we get into your new book, Interstellar, and your important new Galileo project, let's talk about Oumuamua, the star of your recent bestseller book, Extra Terrestrial, the first sign of intelligent life beyond Earth. Now, in 2017, a large object came charging into the solar system, which didn't match our understanding of meteors, nor feature on our list of returning comets. Now, Avi, let's start telling the listeners this extraordinary list of 6 features about this object, 6 anomalous data points that threw you deep into the SETI debate and through the cosmology and astronomy community into chaos, arguing about its nature and origin. Let's start with that story.
Right. So once again, I was driven by the data. It was most natural to assume that this object that was discovered by a telescope in Hawaii, Pan-STARRS, as a near-Earth object, and they measured its speed and realized, it came from outside the solar system because it moves too fast to be bound to the sun. It was most natural to assume that it's a rock, just like the rocks we see around the sun as part of the solar system that came from another star. That's all. But there were issues with that. First of all, the reason it intrigued me, the discovery itself, is because a decade before that, I wrote the first paper that forecasted how many rocks should be around from other stars flying through the solar system. These are interstellar objects. And we calculated that this telescope in Hawaii, Pan-STARRS, will not detect any of them because it's sensitive to an object the size of a football field. We are seeing objects by the reflection of sunlight, and the object needs to be big enough to have enough light reflected in our direction into our telescopes for us to notice it. So we did a calculation based on what we know about the solar system, and it was off by somewhere between a factor of 100 to 100 million. In other words, too few rocks are expected to come our way for these telescope pan-stars to detect any of them from outside the solar system. Okay, during the time that it was observing, during a decade or so. And so I didn't expect it to be found. And then when it was found, it meant there are many more objects in interstellar space than we expected by orders of magnitude. So that's intriguing, but it could still be rocks. That it's just that there are many more rocks being thrown out of planetary systems like the solar system than we expected. Okay, and then shortly after it was discovered on October 19th, 2017, within a couple of weeks, it became clear that this object has an unusual shape because the amount of sunlight that was reflected from it changed by a factor of 10 as the object was tumbling every 8 hours. And that's quite unusual. It means that projected on the sky, the surface area of the object changes by a factor of 10. Just think about a piece of paper tumbling in the wind. It's very unlikely for you to see it edge on. So seeing a variation in the area projected along the line of sight by a factor of 10 is really quite unusual. And it meant the object has an extreme shape. And when people try to model the variation of reflected sunlight, the conclusion was that it must be pancake-like, flat, which again is quite unusual for a rock. And then, so that's another anomaly. Then it was realized that it actually came from a very special frame of reference. It's called the local standard of rest, which is the frame that you get to when you average over the random motions of the stars in the vicinity of the sun. So every star has some random motion in the local galactic frame, and the sun as well is moving at tens of kilometers per second relative to that frame. But you get to that frame when you average over the local population of stars. And turns out that Oumuamua was at rest in that frame, just like a buoy sitting at rest on the surface of the ocean, and the solar system bumped into it like a giant ship. So only 1 in 500 stars is so much at rest as Oumuamua was, and it couldn't have come from any of the nearest stars because it's very rare. And so that was another anomaly. And then the object did not evaporate. There was no cometary tail visible. And moreover, the Spitzer Space Telescope looked very deeply around the object and didn't detect any carbon-based molecules. Another anomaly, it's not a comet, because some of the rocks we see in the solar system, they are covered with ice, and especially those that we expect to be ejected from other stars would be covered with ice because they originate in the outer parts of the planetary systems where ice is very common because it's far from the star, so everything freezes. If there is ice covering an object, you would see a cometary tail. The ice would evaporate when the object comes close to the sun, and then you end up with a tail that includes dust and gas evaporated from the object. And it's very visible because it scatters sunlight. We didn't see that. And moreover, when the Spitzer Space Telescope looked very deeply around Oumuamua, it didn't detect any carbon-based molecules. So the limits were very tight. Basically, practically, there is no evaporation whatsoever. That's another anomaly. It's not a comet. And on that, I should say, a colleague of mine just a few months ago wrote an article about Oumuamua, a review paper, and said, I just finished my review about the comet Oumuamua. And by the way, it's called Oumuamua because it's scout in the Hawaiian language. That's what it means. And I said, we both know that it was not a comet because there was no cometary tail. Why do you call it the comet Oumuamua? And he said, well, I have this theory that maybe there was a cometary tail when we didn't look at it, and there was no cometary tail when we looked at it. And I said, well, that's just like going to the zoo and looking at an elephant and saying that's a zebra and it shows its stripes when we look away. Okay, so anyway, that's another anomaly. There was no cometary tail. It's not a comet of the type that we are familiar with in the solar system. And then the most striking anomaly was that when the trajectory of the object was monitored, it was smooth. There was no evidence for kicks that the object would get, as in the case of an evaporating object because of jets on the surface. And moreover, the trajectory exhibited an excess push away from the sun. There was some mysterious force pushing it, but without cometary evaporation, it was not clear what can do it. Usually, cometary evaporation has the rocket effect, basically pushing the object, but there was no evaporation. So what could push it? And the only thing that came to my mind was sunlight. The object reflects sunlight. We see that reflection. And that could push it if it's thin enough, like a sail, very thin object, if it has a large surface for its mass. And I suggested that maybe it's artificial in origin because nature doesn't make very thin and stable and flat objects. And turns out that 3 years later, the same telescope in Hawaii detected another object in September 2020, and that was given the name 2020 SO. And that object also showed push away from the sun as a result of reflection of sunlight, no cometary tail whatsoever. And a few weeks later, the astronomers realized, it actually, if we go back in time, it looks like the orbit of this object came from Earth. And it was actually identified as a rocket booster that NASA launched. And it was made of stainless steel. And it had thin walls. And that's why it was pushed by reflecting sunlight and didn't evaporate as a comet. So we know that it's artificial because we made it. The question is, who made Oumuamua?
So given those very, very compelling data points, talk us through your process in those first months as you started to put the pieces together. You must have considered every possible natural origin. I know your colleagues proposed something. What possibilities did you run through, and what possibilities from your colleagues were proposed, so we can compare it to your technological relic hypothesis?
Right. So the most likely way out, as far as I'm concerned, is that the observers made a mistake. Okay, that in fact there was no force pushing it away from the sun. And we went over that with one of my postdoctoral fellows, and it looked like they did the correct calculation based on the data. Okay, so I didn't see that they made a mistake. And then with respect to the nature of the object, some of my colleagues suggested a natural origin. They didn't want to consider an artificial origin. I wrote a paper about it. It was accepted for publication within a few days, and then there was a huge pushback from the scientific community, but also a lot of media attention. My book, Extra Terrestrial, was dedicated to this object, and I had about 2,000 interviews over the past 2 years on that object. And so altogether, there was a lot of attention, but my colleagues in academia, they tried to explain it as a natural object. And there were 3 main proposals. One, that maybe it's a dust bunny, some collection of dust particles very loosely bound, 100 times less dense than air. And the problem with that is, the idea is that it's so lightweight, like a feather, that it would be pushed by reflecting sunlight. And the problem is that it wouldn't sustain the heating by the sunlight, which would heat it up by hundreds of degrees, and it would basically lose its integrity, such a cloud, 100 times less dense than air. So then there was another proposal. Maybe it's a hydrogen iceberg. So it's actually a comet, but made of pure hydrogen, something we've never seen, cannot be made in planetary systems like the solar system. It has to be made in molecular clouds. We've never seen a chunk of frozen hydrogen, solid, that is the size of a football field. But nevertheless, the main issue, so the idea is that when hydrogen evaporates, you'll get a cometary tail, but it would not be visible because the hydrogen is transparent and therefore we couldn't see it. So the problem with that is that hydrogen evaporates very quickly. And so such an object would not survive the journey in interstellar space. And so someone else said, yeah, we accept that, but maybe it's a chunk of frozen nitrogen chipped off the surface of a planet like Pluto that has solid nitrogen on its surface. And the problem with that, if you go through the numbers, is that you don't have enough solid nitrogen. If you take all the exoplutos around all the stars and make some generous assumptions, there is just not enough solid nitrogen to account for a big enough population of objects like Oumuamua so that one of them would be observed by pan-stars. And so at any event, these suggestions were of an object that we've never seen before, okay? And why should the first interstellar object be of a type that we've never seen before? And if so, why couldn't it be artificial in origin? That was my question as a kid. I basically said the emperor has no clothes. In this case, Oumuamua has no cometary tail. That's the clothes that usually experts dress up familiar objects with. And so I entertained the possibility that it's artificial. And since then, we discovered two objects that actually predated, that were discovered before Oumuamua and came from outside the solar system. They were both meteors. They collided with the Earth and burnt up in the Earth's atmosphere, detected by US government sensors, one of them in January 2014 and the second in March 2017. So the first one is almost 4 years before Oumuamua. It was moving very fast and it couldn't have been bound to the sun before it hit the Earth. And from the government data, we inferred that the material strength of that meteor was tougher than iron, and actually tougher than all meteors, all space rocks in the catalog, 272 of them, in addition to this one. And so the question is, what was it made of? Why is it so tough? And why should the first interstellar meteor be an outlier? And so it exploded about 100 kilometers off Manus Island in Papua New Guinea, and we're planning an expedition to scoop the ocean floor just next to where it exploded and look for the fragments from this meteor and try to figure out whether it was made of some natural material, maybe iron or something else, or maybe stainless steel, some artificial alloy, because that would tell us that it was a spacecraft. Just imagine New Horizons, Voyager bumping into an exoplanet, they would appear as a meteor.
Now, let's move on to this really exciting new book, Interstellar, The Search for Extraterrestrial Life and Our Future in the Stars. Now, you take your relic idea a step further, explaining how we really need to prepare for this next interplanetary step in our technological evolution. And you also explain that contact will probably be very different than everything we expect following all the movies. Tell us what you argue in the book and why you felt compelled to write it, given that SETI hasn't really been the focus of your career.
Right. So first, SETI for 70 years, following the pioneering work by Frank Drake, who passed away in September 2022, not long ago, it was dedicated to search for radio signals, because we started with radio communication and then astronomers said, okay, well, let's try and detect it from other planets. And that's a naive proposition, because already now we're not using radio communication much. We have many other ways of communicating, and also the power that we transmit went down dramatically since the Second World War. But at any event, it's equivalent to waiting for a phone call at home, okay? Because you need the other side to call you, to send a transmission. And it's possible that they sent it 1 billion years ago, and now this signal is 1 billion light years away. And we would never hear it because they're not around anymore, okay? So you need to be lucky to listen when they are transmitting. That's a very different approach than what I'm advocating. I'm saying we missed an opportunity because there is another way to search for technological equipment, and that is looking for a package in our mailbox. Okay, so going out to the mailbox, checking if there is a package is a very different method than waiting for a phone call, because you don't need the sender to be alive. The packages may have accumulated over time. In fact, if there are chemical rockets that were propelled by the fuel that we are using for our space missions, then they would move at tens of kilometers per second. And that is a speed that is 10 times slower than the escape speed from the Milky Way galaxy. So the Milky Way galaxy can be thought of as a basket that keeps all of the debris, all of the spacecrafts that were ever launched, bound by gravity. Okay, and we would find them around even if the senders died by now. And those packages accumulated over billions of years. And I did a calculation. If we were much more peaceful, in the spirit of John Lennon's song Imagine. Okay, so imagine that all humans lived in peace as one, okay, just as a thought exercise. What would happen? Well, suddenly we will have a surplus in our budget. Why? Because we are dedicating, huge amounts of money to military defense-related expenses. So I calculated if we were to take that money that we now allocate to fighting each other, protecting ourselves against each other, which, by the way, is very narrow-minded. It's basically we're fighting on this two-dimensional surface of the rock that we were born on, trying to get a little more territory, trying to feel superior relative to other people, instead of exploring the third dimension of space. So I'm saying, okay, suppose we explore the third dimension. Suppose we start, we change our priorities from fighting each other, which is pretty much what the news is dedicated to every day. If you think about the war in Ukraine and other conflicts, if you change the mindset for us to think about the third dimension, away from this rock, just exploring space, what can you do with the same money? Turns out that we can send a probe to 200 million stars every year. So 200 million probes every year. And if we do it for several decades, up to, let's say, a century, we will basically send a probe to every star in the Milky Way galaxy. Just one civilization deciding for a century to be peaceful, space exploring, can do that. And I'm saying, most stars formed billions of years before the sun. The sun formed 4.6 billion years ago. The peak in the star formation history of the universe was 10 billion years ago. So most stars were billions of years ahead of the sun. And so if there was a similar story of technological civilizations on planets like Earth around them, because we know that somewhere between 3% to 100% of the sun-like stars have a planet the size of the Earth, roughly the same separation. So there could have been someone smarter than Albert Einstein on an exoplanet, another planet, billions of years ago. And there was enough time for that civilization, first of all, to develop much more advanced science and technology than we have, because we had it only for 1 century. And just think what will happen if we had it for 1 million years, for 1 billion years. But moreover, they had enough time to send these probes that would have arrived to us by over less than 1 billion years. So chemical rockets can traverse the entire Milky Way galaxy in 500 million years. So the point is, they could already be here, these probes. And that's not a philosophical question, whether they're here or not. It's just a question of looking up through our telescopes and learning. If they are around, we can learn about new technologies that represent our future. And the way I think of this is that it will improve us. It's sort of like going on a date, okay? So if you think about Enrico Fermi, who asked 70 years ago, he asked the question, where is everybody? And that is a question that is, being asked again and again as Fermi's paradox. And I say this is a question similar to a question that a single would ask, that a single that is lazy, sitting at home and saying, where are my dates? I don't see anyone here. Instead of going out to the street to dating sites and trying to look for dates, okay? And to me, Fermi's question is just like that. And we can improve ourselves by first of all, detecting probes that may exist around us. And only over the past decade, we could have detected with Pan-STARRS, the telescope I mentioned before, objects as big as a football field. And we never launched a spacecraft as big as a football field. So there might be many more objects that are smaller than a football field that we would never notice because they don't reflect enough sunlight. We could notice them as meteors when they burn up in the atmosphere and create a fireball. And, that's what we're planning to check in Papua New Guinea. But my point is, only over the past decade, we started detecting interstellar objects. That was just very recent. And all the searches for SETI were based on a very different approach, looking for radio signals. They may have been misguided. And let's first look up and check before we make a statement, where is everybody? And even if we don't detect anything artificial that came from another planet, even in that case, we have an obligation to go out, to explore the universe. So the way I see it is that this will have an impact on humanity that is huge, either way.
And I quite agree here. And it does seem to me that while no one, including yourself, is claiming that Oumuamua is conclusive proof of a technological relic or of another perhaps long dead civilization, it should be considered with the same rigor as any natural hypothesis proposed by others of your colleagues. But given this really very high probability of other civilizations existing and the relatively high probability of developing technology far beyond our own, given how young our star is and compared to others in the Milky Way, it just seems a matter of time to me before one of these relics passes through our solar system, and we might even be missing them all the time. So
yeah.
What did you do, Professor Loeb? Before you could say big science, you bypassed this taboo and the funding vacuum around SETI research, and you started raising the funding privately for this very, very important Galileo project to start looking out for these objects. Tell us what different methodologies, you've already mentioned one, going to Papua New Guinea, and the instruments and the methodologies that you're going to be using to find these objects next time they're in our backyard, as you call it.
Right. So my book, Extra Terrestrial, came out in January 2021. And within months, there were a huge number of interviews, podcasts, and magazine articles and so forth written about it. And that brought interesting people to the porch of my home. It was during the pandemic. And a few of those were multi-billionaires. They simply came to my home and said, we really like your vision. We heard you, and we are happy to contribute to your research funds. I didn't do any fundraising. They just came to me.
The public are absolutely fascinated.
Yeah. And I should say that it included, for example, a foundation, the Brinson Foundation, who they approached me and said, we would like you to mentor young scientists. So we are happy to provide you with a postdoctoral fellowship that you award to a promising young scientists. And that came out of the blue. I never approached them. They just came to me and said, we like your spirit of innovation and want young people to imitate that. And of course, the danger that I see, my frustration is that when there is a lot of pushback to a simple suggestion of searching for technological objects near Earth, when the young people see how much pushback I get, they get discouraged because the message they get is you pretty much get bitten if you don't follow the beaten path, okay? And that's not the message you want to send. You want to encourage young people to think independently and to open new frontiers and to take the path not taken, which is pretty much what I did with the funds that I received in July 2021, about half a year after my book came out. I announced the Galileo Project, which has three branches. One, indeed, to go to the site of the first interstellar meteor, and there is a second one. We will visit that second, and search for the fragments and try to figure out the composition and tell whether it was artificial or natural in origin. And so we hope to do that in the coming months. We have already a funder. We have a great team of explorers that will join us for the expedition with expertise in such endeavors. The second component of the Galileo project is to look for the next Oumuamua, and that's using the Vera Rubin Observatory that will come online in about a year. It will have a camera with 3.2 billion pixels, 1,000 times more than you have on a cell phone, and it would monitor the southern sky from Chile, the entire sky, every 4 days. So it will likely detect more objects like Oumuamua every year. And we hope to design a space mission that will date the next Oumuamua and come close to it and take a close-up photograph, because a picture is worth 1,000 words, or in my case, 66,000 words, the number of words in my book. And we want to see what it's like. And if it's a dust cloud, we can fly through it. If it's a hydrogen or nitrogen iceberg, once we get close to it, it will be clear. But if it has screws and bolts on it, then we will be able to tell that it's artificial.
I mean, this spacecraft, will it be sort of on hold in orbit? Like, where will it be placed how do you
that's an excellent question, and that's one thing we address in a paper that we just wrote. And it could be parked in a Lagrange point around the Earth, so that it can get on its way early enough and reach. The idea is to rendezvous the object as it comes towards us. It will not chase the object, but come towards where the object is supposed to cross. So be in the right place at the right time, basically. But it's a challenging proposition. It will cost more than $1 billion to do such a mission. However, the expedition to look at meteors costs 1,000 times less. So it's a much more practical component of the project.
Avi, is part of this solution to have not full-size spacecraft, but sort of static cameras kind of littered throughout the solar system? Is this also part of the plan?
Yeah. The thing is that in the past, all the space missions had a very specific target in mind when they were constructed. Whereas here it's a target of opportunity, and we don't know what it will be. So it requires a change in strategy, and NASA or ESA, they never contemplated something that would be able to do that, especially with an interstellar object. ESA the European Space Agency has a mission concept for an interceptor, but it will only be able to maneuver at a few kilometers per second. Here you really need tens of kilometers per second. So this is more ambitious than the comet interceptor that ESA has in mind. At any event, this is another component of the Galileo project, but the third one, which we already have a new observatory following, was inspired by the report of the Director of National Intelligence in the US in June 2021, around a month before we announced the Galileo project, that there are unidentified aerial phenomena, UAP, objects in the sky that the US government is unclear about. The intelligence agencies obviously are interested in any human-made object, especially if it's made in China. There are some of these objects that were not identified, and the government publicly announced that it's a population of objects, and they would never announce it if they had the suspicion that all of them are human-made. And so the question is, what are they? And of course, some of them may be natural. They may be birds, bugs, whatever, or they may be human-made. But even if one is of extraterrestrial origin and it's functional, it would have a huge impact on the future of humanity for us to realize that. And so the Galileo project constructed the first observatory that monitors the entire sky 24/7, takes a video in the infrared, optical, radio, audio, and other types of signals, and records it, puts it on the cloud through an edge computer, and then we're using artificial intelligence algorithms that are trained on familiar objects to identify those objects that are familiar. But then the question is there anything else? And we just started to collect data last month. So the system is operating. I visited it yesterday, and it looks really amazing. This initial observatory cost about $300,000, and there is nothing like it in the world because astronomers are looking at very distant sources. They are usually covering a small fraction of the sky with their field of view, including the Vera Rubin Observatory that will have a limited field of view. So it will basically tile the sky. But what we are doing is looking at the entire sky at all times. And we are doing it in the infrared, in the optical, in the radio, and so forth, and in the audio. So that there is no observatory like it. And moreover, we calibrate our instruments, and the data will be open to the public. And so it's very different than what the government is doing, because most of the data, the interesting data, is classified. And waiting for the government to declassify data is like waiting for Godot in Samuel Beckett's play. So we don't want to wait for that. The sky is not classified, and we hope to collect our own data in the coming months and deliver some interesting results within a year. And that is the third branch of the Galileo Project, which is already functioning. And we're planning to make copies of the first observatory, at least 3 of them, and put them in different locations. And over time, collect more and more data and get to the bottom of what these unidentified aerial phenomena are. So that's the third component. Now, what I should emphasize is that, I've been working in astronomy for several decades. I was the longest serving chair of the astronomy department at Harvard University, 9 years, 3 terms, director of the Institute for Theory and Computation, that I still am, and the founding director of the Black Hole Initiative. I was chair of the board on physics and astronomy of the National Academy. So I was part of the establishment for decades. And I know it very well, but I do think that, our knowledge is just an island in an ocean of ignorance. So we should be open-minded. And the point is that in cosmology, in the study of the universe, all the textbooks, all the conventional discussions focus on dead objects like stars, objects like galaxies, dark matter, dark energy. These are dead entities that have no life in them. And we may be missing something really fundamental. Steven Weinberg, a Nobel laureate, one of the most celebrated physicists of the last few decades, he was responsible for the standard model of physics. He basically said in his book, The First 3 Minutes, he said, the more the universe, the more we comprehend of the universe, the more pointless it looks. And the reason in my mind that it looked pointless to Steven Weinberg is because he was just focusing on dead objects. If we find a partner, it will change our life. It will give a meaning to our study of the universe. It could explain why we exist if that happens to be a gardener that seeded the earth with intelligent life, or if we realize that it can produce life artificially, or even make a baby universe in its laboratories, then it would have the attributes of a divine entity, what religious texts call God. So my point is, the meaning is actually in the living component of the universe, and Weinberg was focusing on the dead component. And that's why he would suggest that the more we comprehend, the more pointless it looks.
Well, this kind of open-mindedness is really exactly what's missing. And it's by no means a banal thing to be looking for. But I'm interested just to get a perspective for the listeners here. Obviously, you've set SETI squarely back in the public's imagination. But what about your colleagues in astronomy? Obviously, I imagine there was a big difference between what they said to you in private and what they've said publicly. What would you say is the proportion, the percentage of colleagues who have publicly admitted that this is a strong possibility?
Well, not many actually so far, but it's shifting. I should say the first paper, just to give you anchor points, in 2019, we wrote a paper with my student, Amir Siraj, that identified the first interstellar meteor from 2014, reported by the US government based on data that was reported. And we submitted the paper to the Astrophysical Journal, Letters, which is the most prestigious journal in astronomy. And it was rejected by several referees who basically argued that we don't believe the US government. And I think they were also making the point, we are the experts. How dare you invade our territory, academic territory, because you don't have a track record there. And we just said, look at the data. That's what the data says. It looks like it's an interstellar meteor. That's all we said. You don't need to be an expert to analyze data and figure it out. Anyway, so they claimed we cannot trust the US government data. And I always thought that we can, because the US government needs to figure out if there are ballistic missiles that will hit Boston or New York City. They need to be, pretty sure about that. So they must have very high quality data. At any event, I was chair of the board on physics and astronomy of the National Academies, and one of the board members was from Los Alamos, and he had friends behind the national security fence. And I told him the story, so he said, I will try and help you get confirmation that your assessment is correct or not correct, depending on the actual data the government has. And then there was another person in the White House at the Office of Science and Technology Policy that even helped us more than that. And it ended up with a letter that was submitted from the US Space Command under the Department of Defense to NASA in March 2022, and said that they confirm that the object we identified with my student was an interstellar meteor at the 99.999% confidence. Okay, that was an official letter from the US government confirming our statement. Okay, so here you have it, a very unusual situation where the US government, the most conservative organization, is backing us up. The Department of Defense is coming to my defense in the face of criticism from the academic community, which is supposed to be blue sky, open-minded. Okay, so what happened as a result? Our paper got accepted for publication in the Astrophysical Journal.
With an apology, I hope. Or
no apology.
An email, something.
No apology whatsoever. In fact, they even asked us to moderate the statements, to say possibly, and basically soften the language. Yeah. Anyway, it was published, and the experts, if you were to ask them, they would still denounce it. But the point is, we are just following the data. We're not doing anything else, which is pretty much what the child who said the emperor has no clothes did, following the evidence, And what happens very often is people prefer to live in an imagined reality, where things fit your preconceptions rather than the other way around. Anyway, so that the government also released data about the fireball, the light curve of this object, which allowed us to conclude that it was tougher than iron and tougher than all the other space rocks in the meteor catalog. So that was really helpful. And the reason I bring this up is just to illustrate that the government is supporting what we do, and the general public is fascinated with it. Okay, and usually what committees that allocate funds within academia claim, they say we don't want to take risks because we don't want to waste taxpayers' money. And I say the taxpayers really want us to study this, and there is zero funding. So I'm really grateful to the public sector that funds the Galileo Project. In a few weeks, I'm meeting with a group of very wealthy individuals, and I very much hope that we will get more support, because we need about 10 times more. We need tens of millions in order to get to the bottom of these unidentified aerial phenomena. We know exactly how to do it. We just need to make more copies of the first observatory and put them in tens of other locations and collect enough data to get to the bottom of it. So we know exactly what needs to be done. And my point is, we are doing it already, and we're not taking money out of other scientific projects. But at the same time, I find it really surprising that there is this pushback. But the change in the attitude is noticeable, because we found a second meteor just a couple of months ago with my student. And that paper claiming that the second meteor and the first meteor were tougher than all other meteors that are known from the solar system, meaning that interstellar objects are of a different origin than planetary systems like the solar system. that paper was accepted for publication. So it was clear that there is a shift, that at least they're not rejecting flatly anything to do with that data set for us.
Well, congratulations, Avi. It's great that that first observatory is now getting data, and it's great that that support from the government is slowly softening your colleagues' conservatism. I mean, this has come up many times on the show that for working scientists dependent on that funding to feed their families, they really do have to be cautious and to be careful and to quite often stick to the consensus without going out on a limb, because they really do risk losing their funding. And obviously it takes brave folks like you to pick up those anomalies and really push science forward. But I really do understand where they're coming from with that conservatism, because, you know, put your head above the parapet and quite often you get shot down, don't you?
I should say that the change for me psychologically was driven by both my parents passing away a few years ago. And then I realized we live for such a short time that we better focus on substance. And rather than try to show off, try to impress our peers. And I don't have any footprint on social media. I don't really care how many likes I have. I just want to follow common sense. And very often the middle of the road that is following common sense is not being followed. That, you know, just like in politics, people take the extremes. You have polarization. And in this case of UAP, the unidentified objects, the scientific community says, we don't want to deal with that. It's, you know, there are all kinds of unsubstantiated claims. Then on the other side, you have believers that do not follow the scientific method. They just talk about eyewitness testimonies. So following the middle ground where you just use scientific data to figure out what these objects are is not being attended to. And that's the only way to break the mold. You know, if we don't find anything new, so be it. We then clarified this puzzle and figured out what these unidentified objects are. We identify them, and then we move on. Okay, forget about them. If we do find something, then it would have a huge impact, if it's extraterrestrial, on the future of humanity. So either way, we are doing a service to society. And you may ask, okay, so what's the rest of the community doing? If you look at theoretical physics, the most popular ideas, there was a hiatus of decades of no experimental data because the superconducting super collider was canceled. And then a whole culture of theoretical physicists emerged where they basically divorced themselves from any feedback from experiments. And they developed ideas such as the multiverse, where, you know, we can never go, and ideas like extra dimensions or string theory that cannot be tested experimentally. They became very fashionable, and these are dominated our time in theoretical physics. And yeah.
I'm still not clear why string theory has received so many billions for so many decades without a single verification. I mean, is there anything to add there, Avi, particularly on string theory? Because it was just obviously recently confirmed that there really is no evidence for it. I mean, why has that received so many decades of so many millions?
Well, so it starts with a new symmetry of nature called supersymmetry, and that was conjectured before supersymmetry, which, according to the Large Hadron Collider, we didn't find evidence for, and in the natural range of parameters. So it was more of a belief system, but a lot of awards, honors, and it was really regarded as inevitable, and that the Large Hadron Collider would confirm it, but it didn't find it. And at the cost of $10 billion, we found the Higgs, that was old news from the 60s. And then string theory was founded on the foundation of supersymmetry, but some of the practitioners say we don't really depend on that. At any event, it talks about extra dimensions in an attempt to unify quantum mechanics and gravity. And why did it become popular? Because it's a sandbox that allows the practitioners to demonstrate that they're smart. And it has, in extra dimensions, in kind of spaces that we've never probed before. For example, they very often do calculations in anti-de Sitter space, which is a special space that we don't live in. we live in a de Sitter space in our universe, and they are talking about the reverse of that, anti-de Sitter, and they say, well, we can solve the equations in that space, and let's just do it. And that's for decades they just solve equations and it's not a description of the reality that we live in. And nevertheless, it's very popular. So you ask yourself, why? Well, first of all, if you say, I don't need any feedback from experiments, I don't need to think about data, I will just work in my preferred reality, that is just like, living in the metaverse or taking recreational drugs. You can be very happy if you have a big enough community of people practicing the same and agreeing to the rules of the road, basically that mathematics is sufficient for this to be a valuable intellectual endeavor. Then you're basically doing mathematics and claiming that you're a physicist. Okay, and that's what happens.
And it's not to take away from the importance of theoretical physics. I mean, Einstein himself created equations that were yet to be proved and went on to be proved up, as much as 50 years later. I mean, it's not to take away from the endeavor, but it does seem, again, not really very data-led if you're not going to abandon such an idea and come up with a new one when there's no data to support it. You sort of...
Yeah, originally there was a motivation to explain the energy density of the vacuum, which is called the cosmological constant. And then it was realized, well, our universe has a cosmological constant, but it's many orders of magnitude below what you might expect. And then string theory predicts 10 to the power 500 possible values for it, or 10 to the power 272,000 in a more recent paper. And basically, it allows an infinite number of possibilities. And the claim is the one that we live in is the one that allows us to exist. Because if the cosmological constant was much bigger, galaxies like the Milky Way would not come to form. And that is not a good explanation because you can't rule it out, basically. The whole idea about physics is that you learn from experience. We could have never imagined quantum mechanics unless we were forced to accept it by experiments. And in fact, Albert Einstein, as much as the general theory of relativity, the theory of gravity that he formulated, as much as it was theoretically driven, it was tested. That's the only reason that it was accepted into the pantheon of physics, okay? And he himself, between 1935 and 1939, made 3 mistakes. He claimed that black holes do not exist. He claimed that gravitational waves do not exist. These are all papers that he wrote. And he claimed that quantum mechanics doesn't have spooky action at a distance. All 3 of them were confirmed experimentally. And the Nobel Prizes over the past 5 years, 3 of them in physics were awarded to the people who detected and basically proved Einstein wrong, detected black holes, detected gravitational waves, and detected the quantum entanglement. And the lesson of that, the moral of that story is that Einstein himself was wrong, which is evidence that the only way to work at the frontier is to take some risks, and sometimes you're wrong because you can't really see the truth. And only experiments will educate us. And if you are working on a subject where in your lifetime there is no way of testing it, you might spend your entire career working on a hypothesis that has nothing to do with reality. Now, this is really sad if you call yourself a physicist. It's a happy situation if you call yourself a mathematician. But if you are claiming that you are, let's say, a shoemaker, okay, and the only thing you can do is bake cakes, that would not be satisfactory as far as I'm concerned. So you can't just do mathematics and claim that you're a physicist.
And this brings us back to belief. You've mentioned belief, obviously, do you believe in UFOs is the famous one. You've mentioned it in terms of physicists pushing out the boat just because their equations are, resolving and saying, well, listen, we believe we will find supersymmetry. Now, you've mentioned in the past the similarity between the limits of science and religious belief, somewhat echoing Sagan's comments on this, actually. That there's a sort of humble religious feeling when faced with this immensity of the unknown and the sort of unlimited potential of potential advances in our understanding, in our science, and our technology, given the potentially millions of years of evolution beyond where we've reached. It reminds me actually of Arthur C. Clarke's comment that any sufficiently advanced technology would appear to us as magic. Tell us what you meant by this connection between religion and science, these two fields that are so often considered in conflict and incompatible.
Right. So I feel that a sufficiently advanced scientific civilization would have, for example, they would be able to produce artificial life in the laboratory. And moreover, quantum gravity engineers might be able to generate a baby universe in the laboratory. So maybe the Big Bang came out of a laboratory of a very advanced scientific civilization that understands how to unify quantum mechanics and gravity and generate a Big Bang. And in that case, it will be indistinguishable from what religious texts called God, because these were attributes to God. And if we realize this to be the case, it will be a way of unifying religion and science. Now, another context where I found a parallel is that last month I was visiting an institute, and in the dining hall I met a physicist that I knew from decades ago, and he's very proud of himself for contributing to supersymmetry, this symmetry we mentioned before. And as we mentioned, the Large Hadron Collider did not find it. So what was the response of the community? Well, some of them said, okay, we just need to build a bigger accelerator and search for it. Maybe it's around the corner. And that reminded me of the Lubavitcher community. In fact, he himself was telling me how fascinated he is with those cults that have conspiracy theories, where if something doesn't quite match their conspiracy theory, they modify the theory to allow for whatever evidence they found. And I thought to myself, well, what is your community doing right now about supersymmetry? But there is this community in Brooklyn that is Jewish Orthodox that believe that the rabbi is the Messiah when he was alive. And the idea was that when he dies, he will come back as the Messiah shortly afterwards. So they built a house for him in Israel that matches the Brooklyn apartment that he lived in, so that he would find the toilets very easily when he goes to Jerusalem and Israel. And so that house exists, by the way. And then he died, and he didn't come back as a Messiah. So then, of course, the interpretation was that we just have to wait. Now you say, okay, well, this is religious belief. And I say, okay, well, look at the response of the physics community who advocated for supersymmetry, given the data from the Large Hadron Collider that it's not there.
Just wait. Just wait. We'll find it. Oh dear,
Yeah.
It's a tough one, isn't it? But I think it's more than this question about the sort of humility that you're advocating in the scientific community. You're proposing that really what we need to do is say we couldn't possibly imagine something so advanced. We're talking about not another 100 years, like pretty much since the Industrial Revolution that we've developed technology, not 1,000 years, not even 100,000. We're talking millions of years. We have absolutely no idea what that will look like, how it will come along, if it will be some sort of biotech that we wouldn't see as tech at all. I mean, what you mentioned about the potential simulation of the Big Bang could even have been arranged by an AI. That, it's really well beyond our imagination. And I think that's the kind of humility that I think we need, is just to say, listen, let's face it, we are at a different level where we wouldn't necessarily be able to imagine this. So we really need to be completely humble. And in that sense, to be open to believing something that we can't yet understand.
Exactly, because exploring the frontiers of science, in my mind, is similar to spirituality. You are exploring the unknown, and you have to be modest about it, because it can be bigger than you. And the point is that, I see it as an opportunity, actually, A lot of people, even Stephen Hawking, was worried about us transmitting any signal because an extraterrestrial technological civilization may be a predator. They may hurt us. I'm not worried at all. I think that we are most likely much more primitive than they are because we just had a century of science. And the way I see it is an opportunity for us to advance, to learn, just like a kid who finds a smarter neighbor, okay, and then or a smarter classmate, and then learns from that classmate. So the way I think of it is an opportunity to get a quantum leap, a giant leap into our future without waiting the extra thousands or millions of years for us to reach that future, and just because someone else did it already.
And we do have some rather urgent problems that they could help shed some light on. And there's another interesting point in there as well about the civilization theory that says that it's very, very unlikely. We see this in the philosophy of philosopher Nick Bostrom, in his talking about simulation theory, that really it's very unlikely that a warlike, destructive, aggressive civilization would get to that point of advancement because they would wipe themselves out in the process on that road of evolution.
Yeah, on that I completely agree with him. The way I think about the universe is very different than the way he thinks. I don't think about it as a simulation. I think about it as reality. Like it's something real. It's not imaginary or fictitious in any way. And of course, I agree with the idea that you can imagine something similar to natural selection that Darwin came across, and you can ask yourself, okay, in interstellar space, what does it mean? And it means that the fittest survives, and the fittest, in my view, would be the most intelligent or the most scientifically advanced, because that guarantees longevity. If you behave in a foolish way, for example, you launch a nuclear war on just to occupy a little more territory on the surface of your planet, that's not a sign of intelligence. By the way, if you look at human history, it's very much shaped by a group of people trying to feel superior relative to other people, and that's not a sign of intelligence. Now, we grew up, we came from a nature where resources were limited. Okay, so then everything was about zero-sum conflicts. Okay, where if someone gets food, the other side loses that food. If someone gets territory, the other side loses territory. But science is not a zero-sum game. Science is an infinite-sum game, because basically everyone benefits from knowledge. And if you look at the value of the most expensive commodities nowadays, they are technological, and the value is thanks to our knowledge, scientific knowledge that led to technological advances that gave values that didn't exist before. Okay, gave values to things that were never imagined, like computers, internet, and so forth. And so my point is that science and technology allows us an opportunity for an infinite sum frontier where we all benefit by cooperating, sharing knowledge. And that is the sign of intelligence. And we are still hardwired to have conflicts because we came out of this natural habitat where we fought for limited resources. But we have to change our mindset. And perhaps, there would be fewer wars in the world if AI systems will be used to make decisions, will advise politicians about the risks and, the likelihood of a negative outcome from some political situation. So it's just like self-driving cars, they don't feel as if they're intimidated if another car crosses them or passes by them in their lane. They don't take it personally. So in the same way, an AI system may not get so upset like an alpha male does when another nation does something that, that is unclear, and so perhaps we will be heading to a better future with AI systems helping us to be more intelligent.
Mm. Now, Avi, I know we're soon to wrap up, so I've got to get this last question in. We spoke about taboos, and you've mentioned the UAP subject, which is the renaming under the Hillary Clinton's when she was foreign secretary. They renamed this UAP to try and get away from some of the sort of loaded term, the UFO term. But you've mentioned it. But we haven't touched it on Chasing Consciousness yet because of the taboo. And I really, really want to approach it very, very tentatively, because many of my listeners won't know about this, even though it is now coming to the fore in a very, very big way, even in Congress. So I'm going to open this discussion on the show through the research of immunologist and geneticist Gary Nolan at Stanford Medical School. Now, I don't usually ask scientists to comment on other scientists' work on the show, because I feel it's sort of fairer to do that when they're here to answer those comments themselves. But I know that you and Gary know each other's work and that you're friendly. And I'm in touch with Gary as well, so I know he wouldn't mind us commenting. But apologies for the preamble here as I just set this up, Avi. So thanks for your patience. Now, Gary Nolan is a professor, an immunologist at Stanford Medical School, and he invents biotech for analyzing blood and tissue and other materials. Stanford was approached by the US government to analyze the injured brains of almost 100 pilots and military experiences. I think about a quarter of them were already dead from their injuries when they arrived, but they'd all been in proximity to various types of strange vehicles, now called UAPs, or unidentified aerial phenomena. And he discovered that there was a mutation in a majority of these brains. But the interesting thing was that he couldn't say if the mutations had been caused by the contact, or the more radical possibility that the propensity to having the contact was in some way connected to them having had this mutation since birth. And there's even more in this Vice magazine article about him analyzing anomalous materials given to him by government sources as well. But first, Avi, I want to get your take on these military experience revelations. Now, in late 2017, New York Times broke this piece about the USS Nimitz Tic Tac incident and the Pentagon's top secret advanced aerial threat identification program, known as ATIP, even when they weren't supposed to be investigating these things. And I'll put all of this in the show notes, listeners, for anyone who hasn't seen this Vice magazine piece on the brains and the New York Times article, because I'm sure, like me, you're going to want to go off and check this, because it really took me by surprise. Before, I really had even no idea that this was actually a phenomena to be taken seriously because of the taboo. To cover this up in broadsheet publishing. I mean, it's been very present in underground culture, but the fact that it didn't get to the broadsheets or the scientific literature, led me to believe it wasn't real. There's multiple corroborative testimonies from jet pilots who got radar blips. There are so many anomalies around that Tic Tac object. I mean, you must have been fascinated, Abby, when you first read about it. And then even more so, now we've got new laws from Congress demanding that military witnesses come and give testimony, both about these contact experiences and about potential alleged black projects trying to develop this. Gary's data, ATIP's data. What do you think, Avi? I mean, what do you make of the last 5 years of revelations about a subject that's been ridiculed for 70 years?
Yeah, I think the most interesting data is not available for us to see. It's classified. And there are politicians and directors of national intelligence who commented on that, and there are reliable people, including President Obama and the former director of national intelligence, John Ratcliffe. And so the point is, there might be something there, but I have never seen the data that is classified, and therefore I cannot comment on it. The data that was publicly available is not convincing. Okay. And my fundamental point is humans are not scientific detectors. Okay. And there is a good reason for that, that you cannot write a scientific paper saying this person told me that. That is not acceptable. Although in the legal system, you can put a person in jail as a result of eyewitness testimonies. And we know of cases where the wrong person was put in jail based on DNA tests afterwards. So, humans have ulterior motives, they have hallucinations, they have wishful thinking. Science should not rely on humans as detectors. Now, if you ask me, okay, there were these injuries of military personnel. Well, there was also the Havana syndrome. And there it's thought to be related to some very powerful radio signals that were sent in the direction of the US Embassy. And so people can get injured from existing technologies. And that doesn't tell us that it's extraterrestrial. It's possible that the government has classified data which is far more convincing than I know of. To me, all these reports say one thing. They are intriguing, and I say, let's collect new data with instruments that we have full control over, that we fully understand because they're calibrated. They're not on a cockpit of a fighter jet that was not designed for anything other than a war zone. Okay, we want it to be scientific, so we want to understand how the measurements from the instruments are affected by the sources that the sensors are detecting. What were these sensors doing at the time when the object flew nearby, and so forth. And the only way for us to have full control over it is to build our own observatory and look at the sky, because the sky is not classified, collect the best data. Now we have much better instruments. That's exactly the spirit of the Galileo Project. And we are doing it. So it's not a pipe dream. I have a research team that is doing it already right now, as of a month ago. So I say that's the path forward. Rather than wait for others to do the work for you, you just look at the sky the way astronomers do. Now, suppose someone told you, there are exploding stars in the sky, and the government detected some exploding stars, but you don't have access to the data. I mean, what would you do? You would build a telescope, look at the sky, and look for exploding stars. Okay, so that's what astronomers do. I mean, we don't need to rely on what the government tells us or doesn't tell us. We can look at the sky, except that you need to build a very special purpose observatory that monitors the entire sky all the time for fast-moving objects near us. And that's what the Galileo Project Observatory is doing. So my point is, it's intriguing, not convincing. Maybe there is convincing data that is classified. I don't have access to that. Therefore, I will get my own data. And it will be of higher quality than the data the government reports about, because it's done in the scientific way. The government is mostly concerned with national security issues. And therefore, if it sees something that is not manufactured by humans, or they don't care much about it, they are not engaged in a scientific research mindset, which is very different, because from the government perspective, from a national security perspective, you want to understand what most of the objects are in our sky. Most of them. Why? Because most of them may be related to espionage. Okay. From a scientific perspective, if there is any drone or airplane, I don't care about it. Anything human made is boring as far as I'm concerned. I just want to see if there is anything extraterrestrial. And that would be of no interest to the government. Why would they care about something extraterrestrial? It's not manufactured by the Chinese. It's not spying on the US. It should be everywhere. It doesn't adhere to national borders. So what I'm saying is the scientific approach is complementary. Now, of course, the government is the first organization to notice something unusual in the sky. Why? Because it has to monitor the sky. Astronomers are focused on very distant sources, so they don't look around us. And moreover, astronomers are hostile to the possibility that there might be something of extraterrestrial technological origin. So they're biased. So obviously, the government will be the first to report about something anomalous of this nature, because they monitor the sky. That's their day job. And I say, okay, they are reporting. Let's check what these things are. And that's what the Galileo Project is doing. So it's really simple.
And it's great that scientists like Gary Nolan, who have put their reputations on the line by looking into this topic, are engaging with you and hoping that you, with your open-minded approach, your data-led approach, can help to continue normalizing this topic so we can just stop being so childish about this taboo and just sort of man up and just face the data that is coming. Bearing in
I
mind,
think all it takes is very high quality data, because then whoever refuses to look at that data, would look ridiculous. It will be so convincing beyond any reasonable doubt. So what happened until now is this circular argument that extraordinary claims require extraordinary evidence, but we don't want to look for extraordinary evidence until we have it. So obviously, if you don't invest in the research, in the search, you will not find anything wonderful, if you're not looking for it. And the point is, I'm trying to break this mold and basically collect as much data as we can. And if we detect something beyond a reasonable doubt, I think it will basically switch the mindset of everyone.
Mm. And I do just want to draw attention to those 2 points about the fact that this was physical evidence coming to Gary Nolan's lab, both in the form of these MRI scans, these brains, but also in the form of anomalous materials as well. So listeners, do go and check that Vice magazine link. Gary's very, very straight up about it. He's saying, I'm not going to be shouting this from the parapets, when I get the data, because he's been analyzing these anomalous substances, these materials that have been passed to him. He said, I'm just going to write a paper about it and let everyone else do all the talking. So, Avi, it just remains for me to say, what's next? What's next for you? I mean, has the Oumuamua story changed your life forever? Or will you be back to black hole business as usual soon? I don't think your life's going to go back to normal.
Well, I'm still writing papers on black holes, the first stars. I'm still doing it. But my first priority right now is going to Papua New Guinea a few months, scooping the ocean floor and finding what this meteor was all about. And if we find an artificial alloy, I'll be glad to appear on your podcast again.
Well, that's very, very kind of you to offer straight out of the box there. Avi Loeb, thank you so much for your time.
Thanks for having me.